This machine does not look new. It is just another sleek triangle of composite material and shadow. It is another project birthed by the legendary Skunk Works division, cloaked in mystery. But look closely at the Vectis unmanned stealth fighter, and you will see the quiet end of an era for any adversary that seeks to challenge US dominance. For decades, stealth demanded a compromise. Aircraft performance traded away for the simple ability to hide. Endurance was sacrificed for cost, and autonomy was severely limited by fragile control links. The Vectus erases those compromises. This aircraft is the first unmanned stealth fighter built from the ground up to survive, adapt, and fight alongside human pilots without needing them. It does not replace the pilot. It redefines what the pilot is and what the pilot can command. The creation of the Vectis marks the culmination of 6 decades of US experimentation in radar evasion and combat survivability. The development was handled by Lockheed Martin's legendary Skunk Works, the same team that created the U-2 spy plane, the SR-71 Blackbird, the F-117 Nighthawk, and the F-22 Raptor. The goal was not simply to build another drone. The true goal was to build an autonomous partner that could outthink enemy missiles, outlast enemy fighters, and easily outmaneuver detection itself. The foundation of the Vectis advantage lies in its specialized shape. It features a lambda delta wing with no vertical tails. This shape is sculpted by experts to scatter radar waves in every direction except back toward the enemy's radar dish. The air intake is another key feature. It is an S-duct air intake that is buried deep inside the fuselage. This shields the engine fan blades from radar exposure. The intake also works to reduce heat emissions. Even the geometry of the exhaust is carefully tuned to cool its infrared output. To the human eye, the aircraft is elegant. To enemy radar, it is nothing but a ghost. In modern air combat, sensors rule the fight, and exposure always equals destruction. For the Vectis, its unique geometry is not art. It is simply survival. Lockheed engineers use the phrase best-in-class survivability, but this is an understatement of the true reality. The Vectis does not just hide, it actively manipulates the adversary's perception. The aircraft's radar cross-section is so minimal that it can merge with the background noise of the sky. This makes targeting nearly impossible for any system. When faced with enemy systems designed to track even fast-moving stealth aircraft, Vectis presents erratic radar returns. This confusion in the returns completely breaks down adversary targeting algorithms. This is a humiliation for any defense network. Survivability is no longer just about armor and materials. It is about deception, misdirection, and raw endurance under pressure. But fixed geometry stealth, no matter how good, is not enough to win wars alone. Modern battlefields demand adaptability, and this is where Vectis completely diverges from the traditional, rigid designs. The aircraft signals the end of static stealth. Past generations of stealth aircraft relied on a fixed shape and a set coating to hide from radar. The Vectis changes itself mid-air. Its entire surface is intelligent, active, and reactive.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
Lockheed Martin's Skunk Works has turned the drone's skin into a form of software. This turns invisibility from a static state into a dynamic, continuous action. This breakthrough is called adaptive skin technology. This technology allows the drone to dynamically alter its radar signature in real time during flight. The skin is made of specialized materials and surfaces that can actively change their electromagnetic properties. This includes controlling the reflectivity, absorption, and scattering of radar waves. By modulating these properties as the drone maneuvers, the adaptive skin instantly reduces detectability. It disrupts the enemy's ability to get any consistent radar returns. Modern enemy radar arrays are advanced. They sweep across many frequencies and angles, catching reflections that old, traditional stealth methods cannot suppress. Lockheed's engineers saw the enemy's growing capability. They knew that static materials could not outthink dynamic threats. The answer was to create the Vectis adaptive skin, a living electromagnetic armor that constantly measures, predicts, and modifies how the aircraft is perceived by the enemy. This skin is not just for decoration. It is sensory. It consists of microstructured layers embedded with tunable metamaterials. Each of these microsurfaces can adjust how it interacts with radar waves dozens of times every second. When a radar pulse hits the aircraft, the Vectis instantly decides whether to absorb the energy, deflect it, or completely distort the wave. The enemy defense systems receive inconsistent data. Targets flicker, distances appear to shift, and signatures simply vanish. This goes far beyond the static radar profiles of older stealth fighters like the F-22. Such older profiles collapse in multi-band radar environments. VECTIS does not rely on a fixed shape. It calculates and changes its electromagnetic response dynamically in real time. Its sensors detect the incoming radar's characteristics, the frequency, the polarization, and the angle of approach. And then, the skin instantly alters its own properties to match. Instead of reflecting a predictable pattern, the skin changes its texture, dissolving the coherence of the radar wave. The effect is not just a low radar signature, it is active confusion. Enemy tracking systems lose lock because their return data constantly and unpredictably shifts. In test scenarios, adaptive materials similar to this showed a reduction in radar cross-section beyond 90% across multiple frequency bands. When applied to the Vectus, this advantage becomes total tactical dominance. The core design synergy amplifies the skin's power. The lambda delta wings and blended fuselage minimize radar hotspots while maximizing airflow. The entire airframe is an electromagnetic canvas for the adaptive skin system to exploit. Every curve and panel edge is algorithmically coordinated with the skin's modulation routines. The aircraft continuously recalculates its radar exposure while maneuvering. If it pitches up and exposes reflective surfaces, the skin instantly compensates. If it rolls into a bank, the S-duct shields engine reflections while the skin adapts phase coherence across the leading edge. The drone effectively reshapes its own radar image mid-flight. It maintains total stealth even during aggressive combat maneuvers that would fully expose traditional aircraft to enemy fire. What makes this technology revolutionary is its autonomy. The adaptive skin is directly linked to the onboard AI mission computer. This computer runs complex electromagnetic simulations in real time. The system maps every radar source it encounters and predicts how the enemy sensor will behave. Then, it modifies its own radar profile accordingly. If an enemy radar uses high-frequency bands, Vectis increases absorption. If another sweeps low, it instantly redirects scattering vectors. This intelligence transforms stealth from a passive avoidance tactic into an active deception weapon. Enemy operators may detect echoes that last only a fraction of a second before vanishing.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
These vanishings are then replaced by ghost targets miles away. The drone can even shape false returns, appearing as either much smaller or much larger than it truly is, deliberately misleading enemy defenses. This is not invisibility, it is pure misdirection by dominant design. This evolution is far beyond the codings of the past. Older stealth relied on radar-absorbent material, RAM, but RAM deteriorates, demands heavy maintenance, and only works best at narrow-frequency bands. The adaptive skin replaces this old method with electronic control. Instead of painting stealth onto the jet, the Americans program it in. The surface acts like a vast array of pixels. Each cell is a controllable unit that adjusts impedance and phase. Together, they form a high-resolution radar cloak capable of seamless, continuous adaptation. Maintenance shifts from chemical upkeep to calibrating code. This is stealth built for the digital battlefield, where electromagnetic warfare evolves hour by hour. In modern conflict, survival is about being unpredictable, not just being unseen. Enemy anti-access and area denial zones now bristle with multi-frequency sensors and hybrid tracking systems. A drone that cannot adjust in real time is already destroyed. The Vectis thrives in this chaos, turning the enemy's strength into its own weakness. When multiple enemy radars try to triangulate the Vectis position, its adaptive skin simply desynchronizes the returns. When enemy missile seekers lock on, the drone shifts its signature phase angles, forcing the missile to perform mid-flight recalculations that always fail. The Vectis survivability extends across the full spectrum. Adversary engineers were reportedly stunned by the drone's low thermal footprint and its optical cloaking capability. The unveiling of the Vectis reportedly brought silence to the room. On radar screens, there was nothing to see. On infrared, there was almost nothing. Even trained optical observers could not track it for more than a few seconds in flight. Competing engineers watched their own basic assumptions about physics and materials engineering collapse. The Vectis had done what every adversary designer dismisses as unreachable. It erased its own presence from multiple detection spectra at the same time. The Vectis is designed to manipulate the very way it is seen. Its creators did not stop at radar stealth. They attacked the fundamental way machines emit, absorb, and reflect energy. The result is a combat drone that radiates less heat than the ambient air currents around it. It reflects light in patterns that mimic the surrounding sky. Even in daylight, the drone's surface visually dissolves into the atmosphere. This is not fiction. It is U.S. materials science pushed to the absolute limit. At the heart of the design is a sophisticated thermal management system. Traditional stealth aircraft only manage heat passively through simple insulation or exhaust masking. The Vectis takes a much more active approach. Embedded beneath its composite skin are microfluidic heat channels. These channels circulate a phase change coolant, spreading and dissipating thermal buildup across the entire surface of the aircraft. Instead of a bright, glowing engine core, visible to heat sensors, the Vectis radiates a uniform temperature profile that is nearly identical to its surroundings. Infrared seekers rely entirely on contrast, the difference between the target's temperature and the background's temperature. Vectis eliminates that difference, making targeting impossible. Its adaptive coating acts like a living organism. It senses heat distribution and instantly adjusts its emissivity in real time. As the drone accelerates, dives, or climbs through different atmospheric layers, its skin actively shifts its thermal output to stay invisible. During testing, enemy infrared sensors failed to lock onto the drone, even at extremely close range. Analysts reviewing the failed data described it as simply watching the air move, but not the object causing it. This capability redefines survivability in zones where enemy defenses rely on heat-seeking missiles. It is the difference between an easy target and a ghost. The shock did not end with thermal readings. When enemy optical tracking teams reviewed their footage, they found their cameras had captured nothing but background scenery. The drone's outlines literally dissolved mid-flight. What appeared to be natural shimmer, heat haze, or atmospheric distortion was actually the optical cloaking layer doing its work. Vectis uses a combination of passive and active visual camouflage. The passive layer uses adaptive pigments embedded in a metamaterial matrix that alters its reflectivity based on the ambient light conditions. The active component involves nanoscale surface panels that modulate how light scatters off them. Together, these systems disrupt the shape recognition and color consistency that the human eye relies on for tracking. At the heart of the Vectis capability is pure autonomy. Its onboard artificial intelligence can conduct target identification, evasive maneuvers, and complex mission decisions in mere milliseconds. The aircraft is not dependent on constant remote control, which makes it resilient in environments where GPS is denied or communication is jammed. The Vectis is a self-reliant combat entity. When targeted, it executes defensive maneuvers with timing precision beyond human capability. It deploys decoys, flares, and jamming bursts in perfectly coordinated patterns. Its onboard algorithms assess the incoming threats, calculate the interception probabilities, and respond with optimized countermeasures, all within microseconds. This compression of reaction time is the true essence of algorithmic survival. In the compressed timeline of electronic combat, The margin between survival and destruction is owned by Vectis. The AI behind Vectis does not just follow commands. It interprets the human pilot's intent. Pilots flying the F-35 or F-22 can delegate entire tactical functions to the Vectis swarm. This includes threat assessment, electronic warfare, or countermeasure deployment. In essence, the human pilot gains a second set of hands, eyes, and instincts, digital extensions of their own decision-making, operating at the unstoppable speed of a machine. The absence of a cockpit is not just physical, it is symbolic. The cockpit once represented risk and vulnerability. Vectis moves that center of risk elsewhere, spreading it across an invincible network of machines and humans working as a single entity. For the human pilots, this is liberation from the limits of physiology. For strategists, it is freedom from relying on vulnerable air bases and tanker fleets. And for adversaries, it is a nightmare. An opponent that never tires, never hesitates, and never needs to come home. The Vectis is designed from its inception to operate in perfect tandem with the F-35 and F-22 manned stealth fighters. This is known as collaborative combat. This partnership completely changes how U.S. air power is projected. Instead of one pilot clumsily managing multiple drones through remote control, Vectis acts as an autonomous wingman, capable of independent, intelligent decision-making. It receives broad mission objectives and then instantly adapts its actions based on the evolving battle space. This frees the human pilots to focus only on high-level strategy rather than constant micromanagement. In formation, the Vectis becomes a massive force multiplier. Imagine a pair of F-35s entering heavily contested airspace, with each one shadowed by two Vectus drones. The manned jets serve as the secure command nodes. The drones fan out automatically. One is jamming the enemy radar, another is scouting ahead, and another is carrying crucial strike payloads. If one Vectus is targeted, the others instantly respond, reshaping the formation without any human input. This is distributed lethality in active combat. It means smaller radar signatures, higher survivability, and overwhelming, crushing adaptability. The drone's adaptive skin technology also links to its cooperative AI network. This allows multiple VECTIS units to synchronize their electromagnetic signatures. Swarms of these drones can mimic larger aircraft, simulate decoys, or collectively mask each other from enemy eyes. By coordinating radar reflections across multiple drones, they create controlled electromagnetic illusions. Formations can appear to multiply instantly or vanish entirely. This synergy goes beyond simple evasion. During a strike operation, a lead Vectis may intentionally amplify its radar signature to draw the enemy's attention. Meanwhile, its wing drones suppress their own signatures completely. Once enemy sensors commit to the false target, the roles instantly switch in milliseconds. The AI system executes these shifts autonomously, always prioritizing survivability and deception. This is more than a technological advantage. It is a profound shift in logistics. Historically, escort fighters were the indispensable guardians of strike missions. They protected vulnerable aircraft, maintaining air superiority through human reflex. But now, with the Vectis, that old paradigm is shattered by machine self-sufficiency. The escort role is becoming redundant. Vectis was engineered on a simple, dominant principle. It is a fighter that doesn't need protection from anyone. In a Vectis formation, every platform is both an attacker and a self-defender. There is no vulnerable outer ring or escort perimeter. There are only overlapping spheres of mutual protection, governed by machine logic. In deep penetration mission simulations, this configuration showed an 80% increase in survivability compared to older mixed formations. Commanders no longer need to allocate extra fighters for protection. Every drone carries its own survival toolkit. Operational endurance is another key feature that ensures U.S. dominance. Vectis is built to stay in the fight far longer than its human counterparts. Its efficient propulsion, low-drag airframe, and optimized energy management allow for extended missions deep into enemy territory. Unlike manned fighters, which are limited by pilot fatigue and oxygen supply, Vectis can patrol for hours or even days. It acts as a persistent surveillance and strike platform where the enemy expects only temporary weakness. In contested regions, this endurance is massive strategic leverage. It is the crushing ability to sustain an invisible presence where adversaries cannot sustain any presence at all. Then comes the most radical humiliation for adversaries: affordability. Historically, stealth aircraft meant extravagance. They were built to survive once, but not to return often. Lockheed's engineers designed Vectus for continuous reusability. Its materials and systems balance cost with total durability. This allows it to endure repeated combat sorties rather than acting as a disposable asset. This is an evolution in the economics of warfare. It is a stealth aircraft that is cheap enough to risk, tough enough to keep, and smart enough to always return home. The investment does not vanish in flames. It compounds into overwhelming intelligence. Vectis rejects the old logic of using expendable drones in huge numbers just to overwhelm defenses. Instead, it fights to survive another day, gathering data, refining tactics, and learning from every single encounter with the enemy. Each mission makes the system smarter, faster, and harder for the enemy to predict. This machine is also built on an open systems architecture. The drone is modular by its core design. Every sensor, weapon, and subsystem can be swapped or upgraded without redesigning the core aircraft. This means an operator can configure the Vectis for air defense suppression one day and then instantly reconfigure it for reconnaissance or electronic warfare the next. This approach solves one of defense's oldest and most humiliating problems: obsolescence. In traditional programs, rigid, locked systems meant years of redesigns just to integrate new technologies. VECTIS changes that completely. Allies, contractors, and future developers can plug in new capabilities without waiting for permission. It is a global architecture for a global battlefield, giving nations the flexibility to tailor their fleets without being bound by a single vendor's control. Lockheed's engineers are clear about their intent. Vectis is not an experiment. It is the foundation of future air dominance. It is designed to evolve alongside the next-generation air dominance program. Its software-defined core can synchronize with new communication networks, AI-driven targeting systems, and emerging weapons without any physical redesign. Its digital infrastructure fully supports iterative development. This means its performance can continuously scale with technological advances rather than being crushed by aging systems. The concept changes the entire philosophy of military procurement. Instead of fixed generations of aircraft, U.S. air power becomes a process of continuous dominant evolution. This machine is not designed to be invisible to the enemy alone. It is designed to be invisible to obsolescence. Its autonomy is not complete independence, it is intelligent delegation. It can interpret sensor data, select tactics, and execute maneuvers in real time. Crucially, this balance ensures human accountability while fully exploiting the speed advantage of machine reaction times. In electronic warfare, where a mere second determines absolute success or complete failure, that responsiveness is the ultimate deciding factor. Vectis represents more than a technological achievement. It shifts strategic reality. In traditional eras, air power projected dominance through a visible presence, massive formations of fighters screaming across the skies. Vectis operates in reverse. Its strength is total invisibility. The knowledge that unseen, unstoppable aircraft can operate anywhere, at any time, forces adversaries to stretch their defenses thin and creates crushing strategic uncertainty. This is the psychological weight of invisibility, deterrence through doubt. Adversaries must second-guess every radar blip, every false echo, and every heat signature. This uncertainty paralyzes defense networks, spreads doubt across enemy command chains, and buys time for U.S. assets to strike with total precision. The existence of the invisible autonomous strike drone itself becomes an act of psychological warfare. The human role is not diminished. It is simply refined. The Vectis removes the risk of the countdown measured in seconds for the human pilot. It allows human pilots to command from absolute safety while their autonomous counterparts engage directly in the danger zone. This ensures that human courage is fully protected and sustainable. Each unmanned sortie means fewer human lives placed at risk. Each mission flown deep into enemy territory means extending U.S. dominance without paying in blood. The pilot's instincts once shaped a single jet's destiny. Now, the pilot shapes the behavior of an entire dominant digital ecosystem. The human is not leaving the sky, the human is expanding it. The cockpit has evolved into the untouchable command center. The joystick is replaced by the neural flow of crushing AI collaboration. The US does not just project power, it projects invulnerability. Lockheed projects the first flight of the Vectis for 2027. Its impact is already rewriting military strategy. It represents a new metric for progress, one measured not in raw speed or altitude, but in unstoppable autonomy, survivability, and modularity. The lessons learned from the F-117, the B-2, and the F-35 all converge here. Smaller, smarter, cheaper, and faster to iterate than any adversary could ever hope to keep up with. This machine is the merger of total invisibility and intellect. Its strength is its ability to think like an entire fleet instead of just a single fighter. In the dark geometry of Vectis, stealth is no longer a tool for survival. It is the ultimate expression of dominance by design. The backbone of future US air dominance will not be the loudest jet or the fastest missile. It will be the unseen intelligence orchestrating the skies. The quiet precision of machines designed to think, adapt, and protect ensures that the US will always win. When the Vectis enters service, the world, and especially the adversaries, will not see it coming. That is the entire point. It will operate silently, persistently, and invisibly, rewriting strategy from the background and ensuring unmatched confidence for its operators. As wars evolve into networks of data, deception, and pure endurance, the side that sees without being seen is the side that wins. And Vectis is the first aircraft built not merely to fight, but to outthink the battlefield itself. What you've seen is only the beginning. America's power is just getting started. On your screen is the next video. Click the video, it opens right away, and you'll watch US jets and technology strike even harder.